Hello students. So in the last video we completely discussed about covalent bonding and all the conditions for the formation of covalent bonding. So here students we have two types of covalent bonds which can be expected between the combining elements. One is called as polar covalent bond and other one is called as non-polar covalent bond. Like what does it mean by the polarity? Everything we'll discuss. So let us start the discussion with non-polar covalent bonding. So this non-polar covalent bonding is expected students between the same combining elements. So it is also defined as the covalent bond in which bonded pair of electrons equally shared between the two atoms is known as non-polar covalent bond. Equally shared means covalent bond is equal sharing only. There is no doubt about that. But students, the pair of electrons, you can look at this diagram, look at this picture. So hydrogen, right? Both atoms belong to the same element or not, correct? Both can share one electron each, yes or no, correct? One single bond is there, correct? Now the point is, this pair of electrons between the two hydrogen atoms, where it is located? I mean, is it exactly located between the two atoms, or this pair of electrons, is it shifted any other side? The answer is, this electron pair is exactly located in between the two atoms, students. Why? Because both atoms have same electronegativity. Sir, what is electronegativity? The tendency to attract the electrons. So both have same strength. For example, there is a rope. Okay, a group of members on one side and the group of members on other side, both are pulling the thread, a rope on opposite sides, and both have equal strength. Now what happens to the rope? Does it move any other side? No, it remains same as it is. Why? Because the effect on one side is same as the effect on the opposite side. The strength of one side is same as the strength on the other side. Yes or no? Does the rope moves? Does any group falls down? No, both have equal strength. Got the clarity? Now here also electron pair, both hydrogen have equal strength. Does this electron pair shift towards any other side? No. This is called as non-polar covalent molecule. So where it can be expected? Homoatomic, that means same atoms. Atoms belong to the same element. Look at here, O2, Cl2, N2, F2. The shared pair of electrons is equally attracted by the two atoms. The bond is called as non-polar covalent bond. Not only between them, students, even the linear molecules also, where the forces will be cancelled out. For in them also we can expect this non-polar covalent molecule. So next, polar covalent bond. Polarity, polar covalent bond. This bonding happens, students, between two combining elements of which are different elements. When the covalent bond is there between the different elements, then we can expect polar covalent bond. The covalent bond formed between the two dissimilar atoms of different elements or atoms with different electronegativities is known as polar covalent bonding. Different elements definitely have different electronegativities. So for example, in the heteroatomic, that means different atoms, like look at these molecules, HCl, HF, H2O, NH3, all these are covalent molecules only, but are they same elements, students? No, different elements, right? Now what happens if there are different elements? Now I'll give the same example. There is a rope where two groups are constantly pulling the rope on their side. Now on one side the strength is very high, on opposite side the strength is, which strength? The ability to pull the thread, pull the rope, that strength is low. Now what will happen? The rope will move towards the side which is having more strength. Yes or no? Similarly here apply the same concept. What is the meaning of strength in terms of elements? Electronegativity, ability to attract the electrons towards itself. Yes or no? Previously both are same elements, but here one is hydrogen, one is chlorine. Which is more electronegative? Chlorine. So definitely which has more strength to attract the electrons, to pull the electrons towards itself? Chlorine only. That's why you can see this electron pair between hydrogen and chlorine, there is one pair of electrons, right? One electron belongs to chlorine, one electron belongs to hydrogen. Now this pair of electrons, is it exactly located between the two atoms? No. This pair of electrons shifts more closer to the chlorine side. Why? It has more ability to attract the electrons. That means, sir, is it gaining electrons? Chlorine? No. Sir, hydrogen, is it losing electrons? No. Why? That's why they form a covalent bond. Sir, they don't have capacity to lose or to gain. If still not having the capacity also, they have that little capacity. Yes or no? They show that capacity in order to pull the electrons towards itself, in order to attract the electrons towards itself. So which elements will attract towards itself? The element with higher electronegativity. In these two elements, which is more electronegative element? Chlorine. Chlorine is more electronegative element. So the electron pair is shifted more towards chlorine side. Does it mean chlorine gaining electrons? No. Does it mean hydrogen losing electrons? No. Simply the electron pair is more towards the chlorine side, that's it. Because of this reason, students, chlorine attains a partial negative charge. Why? Because electrons have negative charge. It's not gaining, it's not a clear negative charge, it's a partial. And hydrogen gets a partial positive charge. This is called as polarity. What is polarity? Having this partial opposite charges, positive and negative charges are called as polarity. How do they get the charge? Between the combining elements, two combining elements which are different elements in a covalent molecule, the element with higher electronegativity attract the electrons towards itself. It's not gaining. If it gains, it forms ionic bonding only. It doesn't have that much capacity to gain, but it has some capacity to attract. Understood? That's why the electron pair is more towards the chlorine side. Now in the given example, you answer HF, which is more electronegative. Fluorine, H2O is there. Yes, oxygen is more electronegative. That's why water also comes under polar covalent bond that leads to hydrogen bonding, students. And NH3, which is more electronegative, nitrogen. So all these examples, heteroatomic, we can expect this polar covalent bonding. What is polarity? Getting this partial positive and negative charges. So instead of being shared equally, the resultant covalent bond becomes polar, right? Correct. So that's the difference between polar and non-polar. Characteristics of covalent compounds. Physical state. So what is physical state? Solid, liquid or gas. Ionic compounds, what is the physical state, students? Ionic compounds are all solids. Yes or no? Hard solids. What about covalent? Why they are hard solids? Why? Because all these ionic compounds are arranged in a crystal lattice in such a way which very strong force of attraction that makes hardness. And they are also brittle because when the same ions are overlapped on this by a layer, then they will brittle nature, they will break easily. So here physical state, when it comes to the physical state, what happens? Are they exist as solids or liquids or gases? Most of the covalent compounds exist as liquids and gases, students. So under the normal conditions of temperature and pressure, they exist as gases or liquids of low boiling points. What are the examples? H2O is a liquid. Yes or no, students? Carbon dioxide, it's a gas. And majority of the these organic compounds are gases and liquids. Of course, their waxy solids are also there. So most of these compounds, covalent compounds, why? Because there is no perfect arrangement. Yes or no? It's a single molecule. H2O means H2O only. Sodium chloride means sodium chloride. No, I already explained in the case of ionic bonding. Sodium ion is surrounded by chloride ions. They have sodium ions again. So that's a completely net arrangement. But that arrangement is expected in the case of covalent molecules means absolutely no. Why? Because attractions between the molecules are less here in the case of covalent molecules. That's why, because what that solid or liquid gases means what, students? There should be high attractions between the molecules. Yes or no? If more attraction solid, medium liquid, very least gases. That's what. So they exist as liquids and gases in general at room temperature, melting and boiling points. Ionic compounds have high melting and boiling points. Why? Because strong attractions to break the attractions. There are least attractions are there. So definitely what is expected here? The melting and boiling points of covalent molecules are considerably low, comparatively low. For example, melting point of ice, 0 degree. Do you know the melting point of salt, sodium chloride, which is ionic compound? 1000 Kelvin, more than 1000 Kelvin. Look at the difference, yes or no? So there is a perfect arrangement of crystal lattice here, the lack of crystal lattice. So these compounds have low melting and boiling point, but there are few exceptions are there. For example, diamond. With the exception of few which have a giant three-dimensional structure such as diamond and silicon carbide, carborundum, silicon dioxide, these are the common names, etc. Others have relatively low melting and boiling points. Others have relatively low melting and boiling points, but these compounds, these have some strong attractions between them, perfect arrangement that makes these compounds exceptions which have high melting and boiling points because of the alignment of these atoms in that perfect molecule, in that perfect material. So that's what the exceptions only. In general, low melting and boiling points only, students. So crystal structure, is it expected in the case of covalent molecules? Just now I have told you, crystal structure is not expected, but exceptions are there. For example, diamond. Yes or no, diamond? All are carbons only, right, students? All carbons attached to the carbon. Those carbons again, carbons are perfect arrangement. So few exceptions are there. The covalent substances are composed of neutral individual molecules. Yes or no? Say independent single molecules are there, but ionic compounds are the independent molecules? No. Ions, they are ions, attractions are there. So with weak forces between them, that's the covalent molecules are not closely packed. We don't expect any crystal structure for water, yes or no, for carbon dioxide, yes or no, for methane. So all these are not expected. But however, diamond, silicon carbide, silica, aluminum nitride, etc. are very hard and possess high melting and boiling points because of the network structures. So there are some exceptions. There are some covalent molecules which have high ionic nature, that as well as some covalent molecules with perfect alignment of carbons are expected to have high melting and boiling points as well as perfect crystal structure also. But in general they don't have perfect crystal structure, students, and they have considerably low melting and boiling points. But not only diamond, there are other examples also, like there are rubies, gemstones, everything. Yes sir, and all those what compounds, they are also covalent compounds only. They also have perfect arrangement. So in covalent molecules also there are molecules with some ionic nature. There is a chance for this perfect alignment, arrangement of the atoms, though they have high melting and boiling points. So molecular reactions, ionic compounds undergo ionic reactions, yes or no, positive, negative. Molecular compounds are made by bond, yes or no, we are talking about a bond, a single bond, double, triple bond. So when these covalent molecules, when they undergo chemical reactions, what is expected? Breaking the bonds and the formation of new bonds. Is it expected in the case of ionic? No. Ionic reactions are instantaneous reactions with positive, negative, opposite ions, displacement, double displacement, yes or no. But here molecular reactions, covalent molecules undergo molecular reactions. What does it mean? Bond breakings, bond formations. So undergo molecular reactions. During this reactions, bond breaking and bond making are the same. Electrical conductivity. Ionic compounds are good conductors of electricity. Why? When ionic compounds means pure ionic compound, does it conduct electricity? Pure solid sodium chloride? No. I explain clearly, yes or no. The aqueous solution as well as the fused molten state of the ionic compounds are good conductors. But look at the covalent molecules, are they good conductor? No, the answer is no. Why? Because students, in the case of ionic compounds, there are free ions, they are called as mobile electrons also, mobile ions also. But ions are there. Is this bonding made up of ions? No. Then how we can expect the conductivity of electricity in general? But when is expected, there is a chance for when it will be expected. In the case of polar covalent molecules, yes or no, in the case of any compound dissolved in it, for example, water, tap water, does it conduct electricity? Yes. Does it mean H2 is conducting? No. Tap water contains some dissolved minerals, that's why it is conducting electricity. Students, distilled water, does it conduct electricity? Distilled water is a poor conductor of electricity. Of course, partial positive and negative charges are there, but there is no clear positive and negative charges to act like a carriers of this electricity, yes or no. So exceptions are there. For example, graphite conducts, good conductor of electricity. Graphite is a carbon based molecule with sp2 hybridization. So there is a pi bond. There is a reason for the exceptions are there. So in general, covalent substances are bad conductors of electricity. Substances which have polar character like HCl in solution can conduct electricity. HCl is also polar molecule, covalent molecule. What happens when you add HCl into the water, students? HCl acids in general, they release H plus ions, yes or no? If they release H plus ions, obviously opposite ion is there. So these ions are mobile, yes sir, they are moving in the solution, and if they are moving, they can conduct electricity. Got the clarity? So exceptionally, but in general they are bad conductors. So next, solubilities. About solubilities also clearly we discussed in the case of ionic compounds. What is solubility, students? Solubility means simply attracting towards other molecules or simply getting into the spaces between the other molecules. So here we have a statement called as like dissolves in like. That means ionic compounds dissolve in polar solvents, and covalent molecules, molecular compounds, organic compounds dissolve in organic solvents. So here covalent compounds means in general we have majority in general organic compounds only. So in general, covalent substances are insoluble in polar solvents, yes or no? In general, do these covalent molecules, do they have polarity? In general, no. Exceptions are there, like water, but soluble in non-polar solvents like benzene, carbon tetrachloride, ether, alcohols, etc. All these they are called as organic compounds. Most of the molecular compounds are organic compounds only. They dissolve in organic solvents only. That means same compound solutions. They do not dissolve in polar solvents. Understood? Got the clarity, students? Like this is based on the principle like dissolves in like. Some of the covalent compounds like alcohols, which is a covalent molecule, which is an organic compound, amines dissolves in water due to the presence of hydrogen bonding. Water is also covalent molecule only, but water has the partial positive and negative charges. Yes or no? Partial character. Alcohol also can dissolve in water. Yes or no, students? As well as some amines also, because why? The presence of hydrogen bonding. Solubility explained clearly. Solubility is not simply getting into the spaces. Solubility is about attracting its partial charge with the opposite partial charge. So an opposite molecule partial charge. So that's the reason why in general organic compounds dissolve in organic solvents. Ionic compounds dissolve in polar solvents. Understood? There are exceptions are there. Organic compounds can also dissolve in sugar is an organic compound. Okay. It dissolves in water or not? The same. Next. So next type of bonding, the third type of bonding and the last, coordinate covalent bond, students. Coordinate covalent bond. So it is also a covalent bond, yes or no? It is also a covalent bond, but is it the same as like the previous? No, it's not exactly covalent bond. It's a type of covalent bond. But it's a different, completely different. That's why it is given as a different bond. Coordinate covalent bond. How it is expected, when it is expected, clearly we'll discuss. Coordinate covalent bond. The covalent bond in which both electrons of the sharing pair are contributed by one of the two atoms, and the sharing by both the atoms is called as coordinate covalent bond. The meaning of this statement is, students, in covalent bond, equal sharing electrons takes place. Yes or no? That means if one atom is providing one electron, opposite atom also provides one electron only. If this atom provides two electrons, opposite atom also provides two electrons. That means simply from both equal contributions are there. Yes or no? That is covalent bond. But in the case of coordinate covalent bond, only one difference. The sharing pair of electrons are contributed by one atom only. In the case of covalent bond, both atoms contribute 1, 1, okay, 2, okay, 2, 3, okay, 3. But here 2, okay, from this side only. That means if two elements are combining, only one atom is providing both sharing electrons. That means between the combining elements, only one atom is simply providing both sharing pair. That means one atom acts like a donor, other atom acts like an acceptor. Donor means is it losing? No. Acceptor means is it gaining? No. It is not coordinate ionic bond. Ultimately this is coordinate covalent bond only. Got the clarity, students? What is the difference between covalent and coordinate covalent bond? Their equal sharing, here unequal sharing, which means both the bonding pair of electrons are contributed by one atom only. Other atom simply accepts that. After accepting, this contributing pair of electrons are accepted by influenced by only one atom. No, it is still covalent, influenced by this contributing atom and acceptor atom also. Got the clarity? Let's see some examples here. So representation of coordinate covalent bond. Coordinate covalent bond is represented by an arrow, students. Arrow indicates the left side indicates the donor, right side indicates the acceptor. So the arrow points from the atom donating to the lone pair, accepting it towards the contributing atom. So the atom which contributes the electron pair is called as donor, while the atom which accepts is called as acceptor. So formation of SO2 molecule. Look at here, lone pair of electrons. We already know lone pair of electrons. A pair of electrons which do not participate in the bonding is called as lone pair. Students, look at here. This lone pair of electron from sulfur, students. This lone pair of electron from sulfur is contributed towards the oxygen. Yes or no? So here it is a coordinate covalent bond, as well as if you can see this nitrogen like ammonia boron trifluoride conjugate, students. So in ammonia molecule there is one lone pair of electron. In boron, what is the configuration of boron? 2s2 2p1. Yes or no? Excited configuration is 2s. What is the configuration of boron? 2s2 2p1. What is excited state? 2s1 2p2. There is one empty orbital in boron. So this electron pair from nitrogen will be attracted towards this boron, will be shared towards this boron. Now which element is giving a pair of electrons? This nitrogen from ammonia, sir. No. Which element is accepting boron from this BF3 molecule, sir? No. Ultimately, after the bonding, this pair of electrons are still influenced by nitrogen as well as boron also. But what is the difference? Only one atom is contributing the pair of electrons, like from the molecule. Here it is a molecule. So this is called as a donor molecule, and that one is called as an acceptor molecule, and this bonding is called as coordinate covalent bond. So students, what are the characteristics of this coordinate covalent bond? First of all, to explain all these points, coordinate covalent bond has the characteristics between ionic and covalent. So the melting and boiling points are higher than purely covalent compounds but lower than purely ionic compounds. They are like medium between ionic and covalent. So these are sparingly soluble in polar solvents. Sparingly means by constant dissolving in polar solvents like water, but readily soluble in non-polar solvents. Like covalent compounds, these are also bad conductors of electricity. Students, due to the absence of ions, due to the absence of these positive negatives, they are also bad conductors. Their solutions or fused masses do not allow the passage of electricity. Same, due to the lack of free movement of ions, due to the lack of free release of ions, they are also bad conductors of electricity. The bond is rigid and directional. That means not flexible, and it is very directional. Directional means what? We can represent where the bond is. Yes sir, look at the previous. We are representing or not? Here is the bond. Directional nature. Covalent bonds. So similarly, like covalent bond, even coordinate covalent bond also has a directional nature. Students, that's all about covalent, coordinate covalent, and we already completed ionic bonding also. This chapter is completed. Thank you, students.